So what we'll be learning today, we'll be learning about three-tier architecture actually. So how we design a VPC, how we design a three-tier VPC with a high availability and a fault tolerance. Okay, and what goes into an VPC and how do you architect in VPC? Like how can you design a VPC for three-tier applications like database applications and web applications and database and application tier actually. Okay, so what goes into a VPC? First of all, let's take this is a VPC. VPC is nothing but a portion of network, right? We'll have to create a network. This is the network VPC. Then, so mostly what companies does, like they deploy their applications into a specific region, like US East 1, US East 2, things like that. Okay. So what do you mean by multiple availability zones? Multi high availability applications. That means you can deploy your applications at least two availability zones basically. Okay. So at least two availability zones means create at least two subnets for each tab. One subnet in one availability zone, other subnet is another availability zone. Okay. So each tier means, let's say this is a public facing, which is DMZ layer. Okay. This is in availability zone 1A, for example, 1A availability zone. And this is the another subnet, which is in 1B, same public DMZ layer, like a public facing subnet, right? These two are the public facing subnets. And let's go ahead and create one more subnet. This is for application tier. You can say app tier. App tier 1A. And one more subnet for app tier 1B. App tier 1B. Okay. And these two for DMZ layer. That means these two for public facing applications like web applications, and these two for application tier, and we are going to need two more for database tier, database applications actually. Okay, this is a 1A subnet for database, and this is a 1B. 1A means availability zone A and availability zone B within that region actually. Remember when we select a region, you will have a 6 availability zones in that region, right? High availability in the sense you will have to have your applications deployed to at least 2 availability zones. That makes your application highly available, and a fault tolerance. Okay, this is a database tier 1B. Database tier 1B. So how can you be make sure these are the just sub networks, right? Like subnets. These are the subnets. You'll be dividing your portion of VPC into subnets, but that subnets automatically can't give you the security. Like how can you, if you are naming it as a private, it can't be private like that, right? If you are naming it as a public, automatically it won't be a public, and there will be some configuration changes that you need to make. Okay, so what are those configuration changes actually? So the public facing DMZ layer will be connected to through internet gateway. Expose your applications to the public internet gateway. Okay, And these four private subnets, you till now you just name them private. It doesn't it doesn't automatically get you like a privately security, right? You will have to make configurations. So these four private subnets will be configured with a NAT gateways, publicly facing with internet gateways and privately facing with a NAT gateways. NAT gateways nothing but network access translator. Okay, NAT gateways. But how can you be make sure that these servers and these apps in the private subnet are highly secure? How can you make sure? Actually, public and private will be decided by the route tables actually. So you will have to have at least two route tables, right? With 172 dot blah 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 blah, which will be connected to your internet gateway, which is public. This route table connected to internet gateway, which is public, and I will have to have one more route table 172 dot blah blah blah, which will be connected to your NAT gateway, which is a private. This will make your uh, subnets, public subnets and private subnets. Make sure your route table, which is pointing to your NAT gateway, is a private subnet. Private subnets will be associated with that route table actually, and internet gateway, your route table, which is associated with internet gateway, is a public. Okay, and each subnet will be protected with a NACL, network access control layer actually. Okay, each subnet will be protected with a NACL, which is an extra security for your subnet actually. Okay, whether it's public, private, doesn't matter. Okay, and what is instance type, like instance state law? What we have a security group, right? A similar way, in a subnet level, we have a NACL, network access control. Okay, NACL. So this is the three tier VPC, like a three-tier, VPC architecture. This is how we design. At least, like high availability, in the sense you will have to deploy your VPC into at least like a applications into at least like a two availability zones basically. Any questions till now? No questions? Okay, let's go ahead and create our VPC. Okay. So VPC, and I will create internet gateway, and I will create a NAT gateway, and we'll create a 6 subnets, and we'll configure NACL as well. Okay. So what I'm going to do, I'm going to share my screen again. All right. Okay. So let's go to VPC dashboard. Okay. Let's go to your VPCs. So create a VPC. Yeah, we'll just go with a create VPC, and we can just name it as a VPC group ops. Okay. And we can allocate CIDR 10 dot 99.0.0.0./16. Okay, and we can go ahead and create a VPC. Now inside that VPC, how many subnets we need? We need 6 subnets, 2 for each tier, like a public subnets 2, which is for DMZ layer, and a private subnet for 2 subnets for application layer and 2 subnets for database layer, right? So what we can do, we can go ahead and create our 6 subnets. Choose a VPC that we just created, and a subnet name public 1 DMZ, and availability zone 1A, right? And 10.99.1.0/24. What is this? What does this mean is /16 will maximize your IPv4 chart. If you are, I'm pretty sure you are familiar with it, but if you are not familiar with it, let me explain what it is. Okay. So can you guys see my screen? Can you guys type Y in the chat if you are able to see my screen? Yeah, so this /16, right? You see that /16 means 64,000 range, 64,000 range, right? And we are dividing that /24 means 256. We are dividing this network into small portions of network, which is like 256. /24 means like just 256. You are dividing your pool of network into sub network. Are you guys with me? Can you guys type in the Y in the chat if you're with me? Okay, so let's go ahead and create our that was our first subnet. Let's go ahead and create our second subnet. Choose our VPC and a public 2 DMZ. Okay, this will be 1B, and aside 10.99.2.0/24. Okay, you can just go ahead and create. And we are going to need 4 more, right? So what we can do, just go ahead and app AZ1 application tier availability zone 1. So availability zone 1A, right? And at 10.99.2.0/24. Okay, 21.0.24, and we are gonna have one more app AZ2. That means 1B. So 1B 10.99.22.0/24. So we have 2 after subnets, and we are going to have a database tier AZ1 1A and 99.3.0.3.0 and we'll create one more. This is the final one. So database 2 AZ2, that means second availability zone, which is 1B 10.99.32.0/24. So with that, our all subnets are ready. Let's go ahead and create two route tables. One route table for public tier, which is for internet gateway. One route table for private subnet, which is for NAT gateways. Okay. So let's go ahead and create internet gateway, which is pretty simple and straightforward. Create internet gateway. Make sure that sysops, just a name, anything. AWS apps, we can say AWS apps. Apps means operations, AWS operations. Just to go ahead and create internet gateway. And let's go ahead and create a NAT gateway. Okay. So let's go ahead and create one NAT gateway. Create a NAT gateway. So when you create a NAT gateway, you will have to allocate those subnets actually. So app 1, right? And this is a private. For the NAT gateway. Okay. Let's go ahead and allocate elastic IP, right? And we can go ahead and create a NAT gateway. Okay. Actually, no. So the NAT gateway, you will have that NAT gateway in public tier actually, and you will associate private subnets with a NAT gateway. Let me tell you what does that mean is. Okay. So what does that mean is, can you guys see my chart, right? Can you guys see my paint, right? Okay. So let me go ahead and create a new. Basically, what happens is this is your public subnets, right? And these are your private subnets. So basically, public subnets or like a NAT gate resides in public subnet, and NAT gateways are nothing but network access translators. Let's say these instances that are in private subnet should go through these NAT gateways in order to access the apps in DMZ layer. So apps in this public subnet and this public subnet cannot reach these apps like applications or database apps in the private subnets actually cannot reach them. They should go through these NAT gateways. That is the main reason that NAT gateway will reside in one of those public subnets itself actually. So what I'm going to do, let's go back. So what I'm going to do, let's create route tables first. I'm going to create a NAT gateways as well, but let's create route table first. We have some default route table, but we are not going to use it. Okay. Route table public, and make sure you allocate to your VPC and create one route table, right? And in this route table, this is a public, right? So what you can do, subnet association, associate, you will have to subnet association. So this is a public route table, right? So public route table, what you need to do, you will have to have only public. This route table will be attached to internet gateway. Okay. So, and we'll create one more route table. Right? Create one more route table. Private route table. Allocate to our VPC. And once you get there, edit subnet association. So 1, 2, 3, and 4. These 4 subnets are in private subnet actually, right? And next, what we need to do, we need to create a NAT gateways now. So once we create a NAT gateway, we'll create a NAT gateway plus apps NAT, which will reside in 1B, public 1B or 1A. It's up to you. Public 1A, 1B. Okay. Allocating IP. Creating NAT gateways. And what we will do, we'll go to actions. Okay. So here what we can do, the route table, right? And the private route table, route propagation. You see that? No virtual private gateways. So edit route. Okay. Let's go back. Let's verify that subnet associations. Okay, we have 4 subnets, right? Okay, that is fine. Okay, let's update the route propagation for this route table actually. .0. Now, what we need to do, we need to provide the internet gateway. So is this a public one or private one? Let's go back first. So let's add this public route table to public route actually. So what we will do, we will edit routes, add a route, will allow anything, internet gateway. Did we create internet gateway? We did, right? We did create internet gateway, okay. Let's go ahead and attach that internet gateway. Attach to VPC. Yes, we did attach to that VPC. Now let's go back to our route table. Let's go to public route table first. Route, edit route, add a rule, anything, internet gateway. This is the internet gateway. You can go ahead and attach. So whatever the route going through this route table, it will expose to internet. Excuse me, using internet gateways actually. Now let's go to connect our private route table to the NAT gateways. Okay, so route, edit route, add a rule, everything, NAT gateway. This is a NAT gateway. Creating a route NAT gateway does not exist. Okay, let's make sure that NAT gateway has been attached to our VPC. Okay, let's go back and let's did we okay, this is failed. This NAT gateway is a this is failed actually. Let's go ahead and I cannot delete this. Okay, let's create one more. Public 1A, public 1B, connectivity type. No, our gateway should reach create NAT gateway, and let's see. This is pending status. Maybe it will take a couple of minutes to create our NAT gateway. So once that NAT gateway has been created, we will attach that NAT gateway to our private route table. So that private route table associated with a 4 subnets and a public route table associated with a 2 subnets, right? And the internet gateway will expose the data, will expose the applications to the internet over the internet gateway because we have attached a public route table. So those 2 subnets can be called public subnets. And the subnets that are attached to private route table will be secure, and they reach the applications which are in public subnets over the NAT gateways. Are we clear so far? Are you guys with me? This is still pending. So what we do, we can just recap what we have learned just now. With that, so we have designed our 3-tier VPC, but I can recap one more time. Okay, so what we have done, we have created a VPC. Okay, this is a VPC, virtual private cloud. Okay, and we have created 6 subnets. One one is in one availability zone, other is in a different availability zone. So one for example, we have deployed our VPC into ES East 1, right? And availability zones are 1A, 1B, 1C, 1D, 1E, 1F, right? And one subnet is in at least 1A, and one subnet is in 1A, one subnet is in 1B, at least two availability zones. That will make your application highly available, high availability, fault tolerance, right? That's what we discussed, right? High availability and fault tolerance. So that's what it mean actually. Okay, let me stop. So with that, we have designed our 3-tier VPC, but let me go back.